A very good evening, ma'am. My name is M. Varshasri. My roll number is 234G1A33I1. I am studying in second BTech first semester in CSM branch, and today I am here to give a PowerPoint presentation on the topic semiconductor RAM memory for the subject Digital Logics and Computer Organization, and the subject code is 23ECE307. The introduction to semiconductor RAM memory. The semiconductor RAM, the random access memory, is a type of volatile memory used in computers and electronic devices. It allows data to be read and written quickly and making it essential for the system performance. Different types of RAM cater to various applications, influencing the speed and the efficiency. The types of semiconductor RAMs. The main types of semiconductor RAM are DRAM, that is the dynamic RAM, and SRAM, that is the static RAM. The DRAM, which is the dynamic RAM, is slower and needs to be refreshed periodically, whereas the SRAM, that is the static RAM, is faster and more reliable compared to the DRAM. Each type of serves specific purposes, with DRAM commonly used for the main memory in the computers. The semiconductor memory technologies are divided into the two types. One is RAM and the one is ROM. In the RAM, it is again divided into the DRAM and the SRAM, where the SRAM is more faster and more reliable compared to the DRAM. The dynamic RAM, that is the DRAM. The DRAM stores each bit of data in a separate capacitor within an integrated circuit. The charge in the capacitor can leak away, necessitating the periodic refreshing to maintain the data integrity. Due to its high density, DRAM is widely used in the personal computers, laptops, and servers. The dynamic RAM needs one transistors and one capacitors per bit. The stores each bit in a separate capacitor, as a real-world capacitors are not ideal and hence leak electronics. The information eventually fades unless the capacitor charge is refreshed. It is less complex than the SRAM, have high density than the SRAM, and it is less expensive also. The static RAM. The static RAM uses bistable latching circuitry to store each bit, making it faster than the dynamic RAM. It allows and does not allow the required refreshing, which allows for the quicker access times for frequently used data. The static RAM is typically used in the cache memory for CPUs and other applications requiring the high-speed data access. The performance characteristics of the two RAMs. The random access memory performance is categorized by the speed, latency, and bandwidth affecting overall system efficiency. Speed is often used in the nanoseconds, with lower values indicating faster access times. The bandwidth refers to the amount of data that can be transferred in the given time, influencing the multitasking and the capabilities of the given product. The memory hierarchy in computing. The random access memory is a crucial part of the memory hierarchy, sitting between the CPU and the storage devices. It provides the temporary storage for data and instructions that the CPU needs quickly. This hierarchy optimizes the performance by balancing speed and capacity across the different types of the memory. In the given diagram, under the primary stage, the registers, the cache, and the main memory comes. And on the CPU, the registers have the 1 cycle, whereas the cache memory has the 10 cycles. The main memory is approximately considered as 100 cycles, faster access. The flash disk is 1 million cycles. The traditional disk is 10 million cycles. The applications of RAM. Semiconductor random access memory is used in various devices, from the smartphones to high performance computing clusters. In gaming, RAM impacts the load times and frame rates, significantly enhancing user experience. It also plays a crucial role in data centers, where the large amount of RAM support, virtualization, and cloud services are used. The future trends in the RAM technology. The emerging technologies like 3D NAND and MRAM, that is magnetoresistive RAM, promise to enhance the performance and the capacity. The research is going into more efficient and energy saving memory solutions with a lower latency. The innovations in random access technology will continue to drive the advancements in computing and the electronics. The challenges in random access memory development. One major challenge is the physical limitations of miniaturization, which can affect the performance and the reliability. The heat generation in high performance random modules can lead to the thermal throttling and the impacting the speed too. The demand for higher capacity and speed requires the continuous research and development in the semiconductor materials. The conclusion. The semiconductor random access memory is essential for the modern computing, impacting the speed and performances across the many devices. Understanding the types and characteristics of RAM is crucial for optimizing the system design and their applications. As technology progresses, the evolution of the random access memory will continue to shape the future of the computing. The development of the power semiconductor devices is very essential for the modern electronics. The power devices based on the new structures and the materials are promising and commercially realistic for the future electronic developments. Thank you for giving me this opportunity to give a PowerPoint presentation on semiconductor RAM memory.